Hello students, welcome to Solid State Physics lecture number 4. I'm Dr. Pervaiz Ahmad. In this lecture we are going to have a discussion on a type of the crystal lattice. So let's proceed towards today's lecture, that is the type of the crystal lattice. So the first type that we have is called Bravais Lattice. So what is mean by the Bravais Lattice? So just like you can see by yourself, Bravais lattice is an infinite array of discrete points with an arrangement and orientation that appear exactly the same from whichever of the point the array is viewed. So what it means? It means that lattice is invariant under a translation. The second type that we have is called non-Bravais lattice. So what is mean by non-Bravais lattice? So in non-Bravais lattice, not only the arrangement but also the orientation must appear exactly the same from every point in a Bravais lattice. I mean, this is the difference between a Bravais and non-Bravais lattice. So we have some further difference between a Bravais and non-Bravais lattice. So here you can see alternative red and blue points. So the red side has a neighbor with immediate left. The blue one instead has a neighbor to its right. I mean, here you can see this is the red one. So here is immediate neighbor. Here we will have on the left. Here we didn't put, but you should imagine it's been a combination of alternative red and blue point. So just like that, I mean, here at the right, here we will have a red point here, I mean a measure to this blue one, and here so on. The red sides are equivalent and have the same appearance. I mean, the red sides are equivalent, they have the same appearance, and just like that, the blue sides, they are equivalent and they will have the same appearance. So if we consider individually, I mean, if we consider the red and the blue ones to one another, so red and blue sides are not equivalent, but their same appearance can be obtained by rotating the blue side by 180 degree. I mean, if we have a look on the blue and red, so you will come to know that both of these, they are not equivalent. But if we rotate this one, I mean the blue one, with the angle equal to 180 degree, so it will look like the same, just like the red one. Translations lattice vectors in 2 dimensions. So in order to understand the translational lattice vector in 2 dimensions, for that you have to consider this figure of a lattice. In this lattice, you can see that we have different points, that is we have points A, B, C, D, P, and here you can see we have the origin. So let's try to understand the translational lattice vector in 2 dimensions. So we have a space lattice, and you remember a space lattice is a set of points, just like you can see it here, such that a translation from any point in the lattice is given by the vector R with the subscript n, that is equal to N1a plus N2b. So I mean, what it mean? It means that this is a vector located in exactly equivalent point, that is a point with the same environment as P. So this is translation symmetry. So the vector AB are known. I mean, here you can see we have vector. This is vector A. This is vector B. This is vector B dash. So this we call the translation symmetry, and the vector A, B are known as the lattice vector. I mean, this vector A and vector B, we call them as the lattice vector, or they are known the lattice vector. And N1 here in this equation, N1 and N2, this is a pair of the integers whose values depend upon the lattice point. So in order to understand the concept, I mean the value of A and B and N1 and 2, So here we have considered some points in this lattice. I mean, for example, the first point that we have considered is point D. So the location of the point D and this lattice from the origins is being given by N1 and N2, so that is equal to 0 and 2. I mean from the origins, so along one direction, that is, I mean along the x-axis, since we are talking about two dimensions, that is in a plane. So along the x-axis is located, the point is located at 0, but along the x-axis is located on the 0, but along the y-axis here you can see is point 1 and 2. Location is I mean it's a 2 point away from the origin. So similarly, if you talk about the point F is here. So along the x-axis, I mean it's located at the origin, but along the y-axis is located at -1. I mean it's located, I mean it's on the other directions on the of the lattice. I mean I hope you understand that. I mean what I mean. I mean from the origins we are going in the other into the other quadrant. So lattice vector in 2D, the two vectors A and B from a set of lattice vector for the lattice. I mean here that I already mentioned from the previous slide. So the choice of the lattice vector is not unique. I mean we remember this choice of the lattice vector, this is not unique. Thus one could equally will take the vector A and B as the lattice vector. So how we can do how we can deal with the lattice vector in 3D. So just like we have the concept in 2D. So an ideal three-dimensional crystal is described by three fundamental translation vectors. So here you can see these translation vectors are vector A, vector B, and vector C. So if there is a lattice point represented by the position vector R, I mean here you can see it. So then there is also a lattice point represented by the position vector U, V, and W, and we remember U, V, and W, these are arbitrary integer. So here the translation vector I mean is represented by R dash, and R dash is equal to R plus UA plus VB plus WC. We call, for our easy understanding, we give this equation a name, that is equation number 1. I mean this is the translation vectors for the lattice in 3 dimensions. So here you can see Pervaiz lattice in 2D. So this is the general lattice, general Bravais lattice. So if we proceed clockwise, so clockwise here we can see we can translate we can transfer them the general Bravais lattice into center rectangular, and from center rectangular we can go to hexagonal. But if we go anti-clockwise, so anti-clockwise we can go into rectangle, and from the rectangle we can go up to square. So that's all we have for this lecture. I mean crystal lattice type, that is Bravais and non-Bravais lattice. Hope you enjoyed the lecture. So stay tuned for the next lecture, because the next lecture we are going to discuss about the unit cell. So stay tuned for the next lecture. See you then.